plotting points. The first bullet means you're going to plot points, which you probably feel like you know how to do already. Hey, how you doing? Okay. Then distance formula, midpoint formula, finding intercepts. And probably the one that, if it seems foreign at all, it's this last one. But that's probably like the most important one of them all. Okay. So plot points. Remind ourselves, how do we plot points? First of all, they called this a kind of a funny name, which if you haven't heard it before, they call it Cartesian, right? Cartesian. Do you know where that comes from? That comes from, it's the last name of a very famous mathematician named Rene Descartes, right? It comes from his last name. He's the one, before Descartes comes along, math was geometry, basically, right? It was, yeah, they did equations and things like that, but they didn't have this kind of thing yet. I don't know how many of you have kind of ever noticed that picture right there. It says, "Welcome to the dark labyrinth." But that comes from a quote from a guy named Galileo, which you've probably heard of if you don't remember who he was. But you can see in this quote, because Galileo was before this guy, that what math was at that time. He says, "Philosophy is written in this grand book, the universe, which stands continually open to our gaze. But the book cannot be understood unless one first learns to comprehend the language and read the characters in which it is written. It is written in the language of mathematics, and its characters are triangles, circles, and other geometric figures, without which it is humanly impossible to understand a single word of it. Without these, one is wandering in a dark labyrinth." That's where that comes from. So that's what it was. Descartes comes along somewhere in the 50 years after that and says, hey, what if we assign a unique, we're going to make this thing, which we're calling the Cartesian plane, which I'm sure he didn't call that, and we're going to assign each point in the plane a unique address based on how far it is to the left and right, and how far it is to up and down from the middle. Do you remember what we call the middle? It's the origin, right? The middle is the origin. So every point in the plane has a unique address. When was it? In about 1979, I moved to a small town in Utah. The towns out there, because they were developed so long after, the East Coast. In the East Coast, these towns were designed and everything before you had cars or a lot of industry or anything like that. So you've had narrow curved streets and things like that. But in the West, a lot of their cities, no, they made cities that look like that. Everything is perfectly, rectangular. And they even named their streets there's always Center and Main. Okay, that's always the way the streets are named. But the name of the street 1 block north is 100 North. And the name of the street 2 blocks north, 200 North. And the name of the street 1 block west, 100 West. So in those days, before Google Maps or any of that, when you got to town, you had to set up all your services, because then you couldn't just do it on the computer. You got all these addresses, where to go in town. And, they were all addresses like this, go to 300 North, 200 East. Okay, boom, boom, there it is. That's the office. All set up, and just like we set up a coordinate plane. I lived at 135 West, 800 North. So you go 8 blocks north, a little more than a block to the west. That was my house, apartment at the time. Right, but this is coordinate plane. Now, what do we call these two big fat lines? Right, so this is the origin. I don't want to mess up what we do. That is the origin. Right, this is the y-axis, and that's what we're going to call that's the address that goes up and down. How far you are up and down is the y coordinate. This is the x-axis, and how far you go left and right will be according to that. So these points, right, ordered pairs they're called, right? These are ordered pairs, x, y, are telling you how much to go left and right, how much to go up and down, where left is negative, right is positive, up is positive, down is negative. These are ordered pairs. That was wrong. Ordered pairs. Okay, so plot the point -3, 2. Which direction am I going to go from the middle? First, in the x direction, I'm going to go -3 means left 3, and then I'm going to go up 2. Okay, that'll be that. Okay, 4, -2. Which direction? Right 4, down 2. 3, 1. Right 3, up 1. 0, -2. 0, -2. And -1, -2. So left 1, down 2. You know, I know that this is kind of review, but I guarantee you when we do things that require you to do x and y axis, sometimes you're putting your y-intercepts over here, right? And that's the x-axis. So we do make some pretty basic mistakes with that sometimes. And this is just to make sure maybe it'll catch one person that didn't quite get that part of it. So plotting points. There'll be a few homework problems that you plot points, right? Those will go real quickly. Right. The distance formula is a way to find the distance between 2 points in the coordinate plane, right? And let me see what my next slide is before I should have probably made a little bit more of a graphic on this, but let me do this. Take my grid. You can watch some of this. Boom. Take screenshot. And back to this. Okay, so if we have 2 points, like here and here, right? Then the distance formula is going to tell you how to find how far apart are those 2 points. And let's see. I think I'll do it like this. Make it a dashed line. Right. Well, the principle behind it is Pythagorean theorem, right? Want to go, even Galileo knew about that, right? The Pythagorean theorem says a squared plus b squared equals c squared in a right triangle. So you make a right triangle, right? You're going to draw a horizontal line to that point. You're going to draw a vertical line there, right? And then we're trying to find the distance between those 2 points. So this can be A, this could be B, and this could be C. Right, so A squared plus B squared equals C squared. In fact, in our case, we're going to call the C D because it's a distance. That's what this is right there. So if A squared plus B squared equals D squared, because that's the distance, then the distance is the square root of A squared plus B squared. Okay. Now, the A, in the way I've drawn it here, is what? It's the change in the vertical, right? So if this point was our x2, y2, and this was the x1, y1, then the length of this line is y2 minus y1. That's what this is right there. That's where this comes from, right? That is like the A squared. And the B squared is, the B is the distance from here to here on a horizontal line. That would be x2 minus x1. And that's this. So that's what the distance, it's just Pythagorean theorem. That's all it is. And if you had trouble, if you just saw it like a formula to memorize, you would probably have more trouble than if you just drew the picture and made yourself a little right triangle and did Pythagorean theorem and then forget about the x2, x1. I mean, this particular one that I drew, you can count the A and the B, right? 1, 2, 3, 4. A is 4. 1, 2, 3, 4, 5, 6, 7, 8. B is 8, right? The square root of 4 squared plus 8 squared. Good with that? Let me do this. So let's do that. So here's a problem, and you're going to have homework problems like this, right? Which is find the distance between these 2 points, right? Now, if we purely do it with the formula, we're going to say we have to assign one of these to be our x1, y1, the other one to be the x2, y2. Does it matter? No, it doesn't matter at all, right? Oh, what's wrong? So let's call this one the x1, y1, and this could be the x2, y2. All right, so we'll plug into this formula. D equals the square root of -3 minus 3 plus 0 minus 1. D equals the square root of -6 squared plus -1 squared, which is the square root of 36 plus 1, which is the square root of 37. And most of these problems, it seems like they leave them as square roots. If you turn it into a decimal, it doesn't matter to me. Now, if I plot those 2 points and made the right triangle, it would look like this. Right? 3, 1 would be here, and -3, 0 would be here. So the right triangle would be this. That didn't work. There, and there, and there. Right, so what is the length of this side of the right triangle? Is it 1. What is the length of this side of the right triangle? 1, 2, 3, 4, 5, 6. So in order to find this one, you do the square root of 6 squared plus 1 squared, which is the same thing. So, I mean, there's a lot of times on tests, you write down the distance formula and you put like a minus in the middle there, or you put pluses there, right? You make a lot of mistakes that are just like, you're going to be wrong if you got the formula wrong. But I don't think you'd make a mistake if you drew a right triangle and had to do Pythagorean theorem. You'd probably count out those squares just fine. Okay. Okay, let's see. I think I've got a... So the next kind of problem is show that points are the vertices of a right triangle. Okay, let's see. Let me plot the points. 2, -1. 2, -1 is here. 5, 5 is here. And 6, -3 is here. So I'm going to connect those up because it's easier to look at them when you do that. So I want to know, is that a right triangle? how can we show that that might form a right triangle? Which is the theorem that relates the sides of a right triangle. We just used it to find the distance. Pythagorean theorem. See whether it fits the Pythagorean theorem. If that was a right triangle, which one of these angles looks like it's probably the right angle? Yeah, this one here, if there is a right angle, it looks like it's probably going to be that one. Okay, we're not sure, but that's what we want to show. Right, well, in order to do that, we need to know the lengths of the sides so we could plug it into the Pythagorean theorem. So that means the distance formula 3 times, right? So let's see, the distance between, I'll label the points so we can use them. 2, -1, go ahead and open it up. 5, 5. And 6, -3. Let's call this is our A, this is our B, and this is our C, right there. So the distance, or the length of A, is going to be the square root of 5 minus 2 squared plus 5 minus -1. Oops, that was wrong. -1 squared, which is the square root of 3 squared plus 6 squared, which is the square root of 9 plus 36, the square root of 45. Leave it like that. Okay, the distance of B, the length of B, actually, will be, I'll use these 2 points, right? So 6 minus 2 squared plus -3 minus -1 squared, which is the square root of 4 squared plus -2 squared, which is 16 plus 4, the square root of 20. Okay, now let's do the last one, the long one. I'll make this would be the x2, y2. This would be the x1, y1. So the distance for C is the square root of 5 minus 6 squared plus 5 minus -3 squared, which is the square root of -1 squared plus 8 squared. 1 plus 64, the square root of 65. All right, now, if that's a right triangle, then it ought to be that a squared plus b squared equals c squared. So let's try it. Where? Yeah, this 5 minus -1. Here? Yes. Because 5 minus -1. Okay, let's try this again. All right, let's see. Is the square root of 45 squared plus the square root of 20 squared equal to the square root of 65 squared? Well, what do you get when you square a square root? They cancel, right? The square of the square root of 45 is 45. So 45 plus 20 equals 65. Is that true? Yeah. So this is a right triangle. True, therefore, right triangle. Right, there's 2 kinds of problems like this in the homework. One of them is just like this. Show that these could be the vertices of a right triangle. The other one is show that these could be the vertices of an isosceles triangle. What would you be trying to prove to show that it's isosceles? What is isosceles? 2 sides are equal, right? If you did this calculation here, 2 of them would be equal. And you'd say, yes, that's isosceles. So one of them, you repeat this process. The other one is a lot easier. If 2 of them are equal, yes, isosceles. should have put a question mark. Good, Ariel? What's that? Okay, great. I'm going to turn on these. You know, you could have, for the distance formula, right, you could have done that Pythagorean theorem, but you would have to do it 3 times, right? You'd have to make a right triangle between these 2 points and use Pythagorean theorem, and then do it between these 2 points, right? Make a little right triangle, and then do it between these 2 points. You'd have to do it on the same graph. It'd probably be kind of busy. Are we done, Julian? All right, then the midpoint formula. Let me go back and grab that guy again. Okay, so let's see. So a midpoint is like halfway in between 2 points. But it's always going to be stated like what would be the midpoint of a line segment that joins the 2 points. But that's what it means. What is the halfway point between these two? Right? If I label it like here and here, right, this could be the x1, y1. And this could be the x2, y2. Right? And then you could join them as a segment, since that's what they said to do. So the midpoint is going to be somewhere in here, and we're just trying to find exactly where. Where is the midpoint? Well, we have a formula for that, right? And the formula, I mean, first of all, recognize that the answer to the question, what is the midpoint, is a point, right? It's something with an x and a y coordinate. It's a point on the graph. It's not just a number. Unlike the distance, it's a number, right? So it's apples and oranges if you give a number for midpoint. So make sure you answer with a point. But if you notice the math here, we're adding up the x's and dividing by 2. What does that sound like? When you add up 2 things and divide by 2. It's the average. That's all this is. The average of the x's is the average of the y's. That's all it is. Right? Average of x's, average of y's. Right? You add them up, divide by 2. In this particular one, if I was going to add them up, it looks like this point is 1, 2, and this point looks like 1, 2, 3, 4, 5, 6, 4. So if I was going to find the midpoint, I would add up 1 plus 6, divide by 2. 2 plus 4, divide by 2. Right, that's 7 halves, comma, 3. That's not a very good 7. And if you want, because we have to find this, that's 3.5, comma, 3. And most of the time when you get this kind of question, you're not asked to graph it. Okay, it's just find the midpoint. It's all. I've never seen it any other way other than that. But if I looked on the graph, it should look reasonable, right? If I got an answer that was way over here, I would know I did something wrong because it's got to be somewhere around here. Let's see, 3.5 would give us right there, and 3 would give us right there. And that looks pretty good. Do you remember midpoint from geometry? In geometry, when you did that, it would say like this is a segment bisector or something like that, and you would know that it connected at a midpoint, and that meant that this is congruent to that, and use a little hash mark to say these are equal. Right? Okay. Okay, so let's find the midpoint. We won't even mess with the graph. Try to find the midpoint between these two. Okay? -2, 8, 4, -10. Good. What's that? Okay. Okay. That's correct. 8 minus 10 is -2. -2 over 2 is negative. Good. So it is, okay, 8 minus 10 is -2. Then you divide it by 2, and you'll get -1. -2 over 2 is -1. Yeah. What is it? It should be 1, -1. Right. 1, -1. -2 plus 4 over 2. 8 plus -10 over 2, which is 2 over 2, comma, -2 over 2, which is 1, -1. You know, a sometimes mistake that we make on this is that, like, you put it in the calculator and you say -4 plus, or -2 plus 4 over 2, and you don't put parentheses around the numerator. So what it does is it does -2 plus 2, 0. 4 over 2 is 2. Right? So make sure if you do it that way, put in parentheses. Okay, x-intercepts and y-intercepts. What do we mean by the x-intercept of a function? Say again? Okay. You know, it might be more accurate to call it the x-axis intercept. That's what we mean, right? It's wherever graph crosses the x-axis, right? All righty. Okay, I'm making this, I might have started this slide at the end of the last video. So this would be a little repeat, but we were interrupted by a fire, not drill, but actually a response to a fire alarm. Finding the x and y intercepts are pretty important skills to have in this level of math and higher. And the thing is that it should make sense to you. You don't want to think of this as like another thing you've got to memorize how to do. You know that on the x-axis, y equals 0, meaning because you're not above the middle or below the middle, and that's what y is telling you, y equals 0. So if you want to know where the graph crosses the x-axis, you substitute y equals 0 and solve for x. In the same way, on the y-axis, x equals 0. So if you want to know where the graph crosses the y-axis, then substitute x equals 0 and solve for y. Right? We're going to end up using this throughout the course for all different kinds of functions, and it always works the same way. And I'll ask, when they say find the x and y intercepts, I'll say, how do you find the x-intercept? And the answer I'm looking for is substitute y equals 0, solve for x, right? Essentially these two statements right here. So here's an example. Find the x and y intercepts of this graph. So to find the x-intercepts, right, I will substitute y equals 0, negative x squared minus 5x, and solve, right? There's a common factor of x, and if I take out a negative, and I'm pausing here to answer the phone. Yes? No. Bye. Right. So I factor out the negative x, and I get x plus 5. And by zero product property, that means that x equals 0 and x equals negative 5. Okay, to find the y-intercepts, I'd substitute x equals 0. Y equals negative 0 squared minus 5 times 0. Y equals 0. Right? It's fairly straightforward process. Just remember these two. They're not going away. They're really important. And I think you actually know why they work. And one other thing that I didn't say earlier when I should have said it, and you might need for your homework if you can't figure it out. I mean, most of this is all review anyways. But remember that when we're dealing in the coordinate plane, the coordinate plane is divided into 4 quadrants, right, by the x and the y-axis. Where both x and y are greater than 0, that we call that quadrant 1. Right? Now you go around counterclockwise, where x is less than 0 and y is greater than 0, we call that quadrant 2. Where they're both less than 0, that's quadrant 3. And where x is positive and y is negative, we call that quadrant 4. So there are some homework problems that ask you about that. And I should have brought it up, and most of you, seems like you already know about the quadrants. You could also just look it up in the textbook in this section, but I wanted to have included that in here. So that's what we did. That's the homework.